Hi all, good morning.
Yes,
Am I audible to you?
yes,
Anybody, please respond. Okay, we can start. Actually, last class we were discussing about the architecture of 8086 microprocessor. Generally, we can divide the 8086 microprocessor architecture into two sections, or we can say two functional units. First one is bus interface unit, this one, and the second one is execution. So these are the two main functional units of an 8086 microprocessor. Okay, so this is the bus interface unit. The main function of a bus interface unit. What are the main functions of bus interface unit? So, bus interface unit, it fetch the instruction and the data from the memory for execution. Okay. So, first function of bus interface unit is to fetch the data and instruction from the memory for executing. And also, by using that bus interface unit, it will write the data to the memory, and also it will read the data from IO port, and also it will write the data to the IO port. Okay. So one more important functions are there in bus interface unit, that is this 20-bit address generation. That means it will generate a 20-bit physical address for accessing the memory. Okay. So these are the important functions in bus interface unit. What are they? It fetch the data and instruction from the memory, and also it is used to write the data and instruction to the memory. No, not instruction. It can write the data to the memory. Okay, and also from IO port also we by using bus interface unit, it can read the data and also it can write. And the last and important function is this bus interface unit is used to generate the 20-bit physical address for accessing the memory. Okay. And these are the functional units or different blocks that are present in the bus interface unit. What are they? There is a segment registers. There are four segment registers are there. Then there is an instruction pointer. Then there is an instruction queue and a address generator, or we can call it as an adder. Okay, adder. So these are the important functional parts that are present in the bus interface unit. Okay. Now first we can see this segment register. Okay, segment register. Actually, in 8086 microprocessor, uh, there are four segment registers are there. Okay, four segment registers are there. These segment registers are used to store the address for accessing the memories. Okay, there are different segment registers are there. It contains the address of instruction and the data in memory, which are used by the processor to access memory locations. Okay, so these are the four segment registers. First one is CS. CS means it is code segment. Then DS, this one is data segment. SS, that is stack segment, and the last one is extra segment. So these are the four segment registers available in the 8086 microprocessor. Okay. Then another register is there, that is IP. We can call it as an instruction pointer. Instruction pointer. Actually, in 8086, instruction pointer is a 16-bit register. 16-bit register that is mainly used to store the address of the next instruction that is to be executed. Okay, so in order to point the next instruction in the memory, so we will use an instruction register. Okay, so This is a 16-bit register, IP. We will, in short, we will call it as an IP. Okay, so IP is an instruction register, which is a 16-bit register, which is used to store the address of the next instruction to be executed. Okay, then next block is instruction queue, or we can call it as an instruction byte queue. Actually, in 8086 microprocessor, instruction byte queue is a 6 byte long queue. Okay, 6 byte long queue. Queue means you know that the main how the queue will work. That means first in, first out manner. Okay, so when an execution unit is executing an instruction, so at the same time, the bus interface unit uh, fetches the instruction code of the next instruction to be executed. So those instructions will be stored in the instruction queue. Okay, so that is why we will call this instruction queue as a pre-decoded instruction byte queue. Pre-decoded instruction byte queue means before executing that instruction, while executing one instruction in the processor, it will fetch the next instruction and that will be stored into the instruction byte queue for executing. So that is why we will call it as an instruction, sorry, pre-decoded instruction byte queue. Okay, so then next one important functional part is this adder. Okay, here in 8086 we already studied that the address bus. So tell me, what is the size of an address, size of the address bus in 8086? Anybody? What is the size of address bus in 8086? Anybody? Size of the address bus? Anybody?
20.
20.
bits. 20.
Okay, 20 bits. Okay, correct. So size of the address bus is 20 bit. So in order to generate the 20-bit address, we need an address translation unit or address generation unit. So this is the address generation unit. So the main function of this address generation unit is to generate 20-bit physical address. Okay, how it will generate the 20-bit physical address? Actually, by using the 60-bit segment register value. So actually, we studied that segment register will store the address of the different segments, memory segments. So it will use the 16-bit segment register, and also it will use a 16-bit offset value to generate the 20-bit physical address. Okay, so address generation unit will generate the 20-bit physical unit by how it will generate? It will generate these physical address by using the address from the segment register and the offset value. Okay, 16-bit segment register and 16-bit offset value. It will generate the 20-bit physical address for accessing the memory. Okay, so these are the different functional parts or important blocks that are present in the bus interface unit. Segment register is the instruction pointer is the instruction byte queue is the and address generator. Okay, actually this address generator is an adder. Then next important functional unit is this one, execution unit. Execution. So we can see what are the important functions in the execution unit. Execution unit means it will execute the instruction that is from bus interface unit. Okay, as we have discussed the bus interface unit, it is the duty of the bus interface unit to fetch the instruction from the memory. Okay, so the execution unit will read the instruction that are fetched from the bus interface unit, then it will execute. So this is the execution unit. This one. Okay. Now we can see what are the different functions. The first important function is it has to fetch the instruction from where it has to fetch the instruction and the data from the bus interface unit. That is the first function. It has to fetch the instruction and the data from the bus interface unit. Okay. Then after fetching that instruction, it has to decode. Okay. Then only the processor can understand what are the different operations it has to perform. Okay. So first function is to fetch the instruction from the bus interface unit. Then it has to decode. Okay. So decoding the instruction, that is the next important function. Then after decoding, it can execute the instruction. So execution of instruction. And also for executing these instructions, the EU unit, that means execution unit, contains some control circuitry to perform some various other operations also. Okay, so these are the important functions. First one, it has to fetch the instruction from the bus interface unit to execution unit. After fetching the instruction, it has to decode the instruction. Then it can execute. Now we can see what are the different blocks that are present in the execution unit. So first one, here you can see that there is a general purpose register. Okay, there is a general purpose register is there. Then there is a pointer and index register. These are pointers and index registers. Okay, these things, pointers and index register is there. Then there is an ALU, flag register, timing and control circuit, decoding unit. Okay, decoding unit. So these are the important functional parts that are present in the execution unit. Okay, that is general purpose registers are the then pointers and index registers, ALU, uh, flag register, timing and control circuit, and decoding unit or decoding circuit. First, we can see the general purpose register. General purpose register means actually in 8086 there are four general purpose registers are there. Four general purpose register A, B, C, D. We can call it like that. A, B, C, D. Actually, these are 16-bit register. So AX, BX, CX, and DX. So these are the four 16-bit registers available in the 8086 microprocessor. Okay, and we can divide these 16-bit registers into two 8-bit registers also. That means it can store either a 16-bit data or an 8-bit data. Both is possible in case of registers in 8086. Okay, you can store either 16-bit data or it can store an 8-bit data. Okay, so AX is divided into two units, that is AH for higher order bytes and AL for lower order bytes. Similarly, BX that will be divided into BH and BL, and CX that is also divided into CH and CL. Then last one is DX. It will be also divided into two 8-bit register that are DH and DL. Okay, so these are the different registers. What is the duty of a register? What is the duty of a register? Abhishek, see. Why we are using registers? Abhishek, see. What is the need of a register in a processor? Are you present? Abhishek? Abhishek? Absent or no? Aditya? Okay, to store data. Correct. To store data, we will use this general purpose registers to store values. Okay. Then there are some pointers and index registers. We already discussed that. So these are in 8086, two pointers and two index registers are there. Two pointers. So these are the 2 pointers. One is stack pointer and another one is base pointer. So these are the 2 pointer registers available in the 8086 architecture, stack pointer and base pointer. We can see the different functions in the stack pointer and the base pointer later. Okay, so we just remember that we will use 2 pointer, that is stack pointer and base pointer. We know that stack pointer. What is the duty of a stack pointer? It will point the top element in the stack. Okay, so stack pointer is the, base pointer is the, and the two index registers are also either. That is source index register and destination index register. Source index register and destination index register. So these are the 2 pointers and index registers available in 8086. Then next unit is ALU. Here in 8086, ALU is a 16-bit ALU. 16-bit ALU, which is used to perform the arithmetic and the logical operation. That is the functions. ALU is the ALU is used to perform the arithmetic and the logical operation. 16-bit arithmetic and logical operation. Not only 16-bit, in 8086, the ALU can perform 8-bit operations also. Okay, we can say that ALU is used to perform either 8-bit operation or a 16-bit operations in case of 8086 microprocessor. Okay, actually ALU is a 16-bit ALU. It can perform either an 8-bit operation or a 16-bit operations. Okay, so that is ALU. Then there is a flag register. So what is a flag register? Flag register. Anybody? Why we are using flags? Flag register. Aishwarya P. What do you mean by a flag? Aishwarya. Aishwarya. What is a flag register? Anupama? Anupama, you.
So, status register alle.
Okay, it shows the status of the operations that is performed in the ALU. Okay, correct. So here in 8086, the flag register is actually a 16-bit register. 16-bit register, but we are using only 9 bits for representing these flags. That means we can say that in 8086 there is only 9 flags are available. Okay, 9 flags are available. These 9 flags, it will be divided into 2 categories. That is, one is 6 status flags are there and 3 control flags are there. Okay, actually flag register is a 16-bit register and total 9 flags are there, and we will divide the these 9 flags into 2 category. One is status or conditional flag, we can say that. Then next one is control flag. So these are the flag registers. 16-bit flag register is there. Then next one is timing and control circuit. Okay, timing and control circuit. Timing and control circuits are used to generate the control signal. Okay, timing and control units are used for generating the control signals in the 8086. Then there is a decoding unit. So what is the duty of a decoding unit or decoding circuit? Decoding circuit will decode the instructions. Okay, so at first the decoding unit will take the instruction from the instruction queue. Okay, from that instruction queue, the decoding unit will take those instructions, then it will decode the instruction. Okay, decode the instruction. That means decode the opcode bytes fetched from the instruction byte, and after decoding that, it will send send the information to the control circuit for execution. Okay, So these are the different functional parts that are present in the execution unit. Okay, these are the different functional parts. What are they? There is a general purpose register, then pointers and index register, then ALU is actually a 16-bit register. Then flag register is that is also a 16-bit register, but there is only 9 flags. Okay, 9 flags. Then timing and control circuit, then decoding circuit. What is the duty of decoding circuit? Decoding circuit will fetch the opcode byte from where instruction Q, then it will decode, then it will send the control those information to control unit. Okay, for execution. So these are the different functional parts that are present in the 8086 microprocessor. That is bus execution unit and bus interface unit. So these are the two functional parts. As we discussed that, what is the duty of a bus interface unit? Sending address, fetching instruction from the memory, reading data from the port and the memory, as well as writing data to the port and the memory. And also, it will generate a 20-bit physical address for accessing the memory. And there are 4 functional parts are the instruction queue, instruction pointer, segment register, and address register. So instruction queue is a 16-byte long FIFO. Okay, so it will execute. What is the duty of an instruction queue? When an execution unit execute an instruction and is ready for the next instruction, then it simply read the instruction from this instruction queue, resulting in increasing the execution. Okay, so this is what we will call it as pipelining. And this instruction queue, we will call it as a pre-decoded instruction byte. And there is an instruction pointer. It is also a 16-bit register, which is used to store the address of next instruction to be executed. Then segment registers are there are 4 segment registers are there: CS, DS, SS, and ES. Okay, CS, DS, SS, and ES. Port segment, data segment, stack segment, and extra segment, which are used to hold the address of the next instruction and data in the memory. Address of the instruction and data in the memory, which are used by the processor to access memory location. Okay. Then there is an address generator which is used to generate a 20-bit physical address from 16-bit segment register and 16-bit offset. Then execution unit. The main important functions of execution units are fetch instruction and data from the bus interface unit, decode the instruction, execute the instruction. Okay. Then execution unit contain a control circuitry to perform various internal operations. And these are the functional part, that is general purpose register, pointers and index register, ALU, flag register, timing and control unit, and decoding unit. So first one is general purpose register. General purpose register means 4 general purpose registers are there: AX, BX, CX, and DS. Each register is of size 16-bit, and also we can divide the registers into 2 8-bit register. That is AX, we can divide it into AH and AL. BX also we can divide it into BH and BL. CX, that is CH and CL. DX, DH and PL. Okay, so this register can use to individually store 8-bit data, and also it can use as a pair to store 16-bit data. And the 2 pointer and index registers are there, that is stack pointer, base pointer, and source index and destination index. Then ALU is the ALU, 16-bit ALU for arithmetic and logical operation. It can perform 8-bit and 16-bit operations. Then there is a flag register. It is a 16-bit register. We have like a flip-flop. There are 9 flags are there, which are divided into two groups or two categories. One is there is 6 conditional flags and 3 control flags, and timing and control circuit. So, which it is the duty of the timing and control unit to generate the control signal. Okay, to generate the control signal. Then there is a decoding unit which decode the opcode bytes fetched from the instruction byte and send it to the control circuit for execution. Decoding unit means which is used to decode the instruction that is fetched from the instruction register. Okay, so these are the different blocks that are present in the 8086 architecture. Clear or not? നമുക്ക് നെക്സ്റ്റ് സെക്ഷൻ എടുക്കാം, ദാറ്റ് ഈസ് രജിസ്റ്റർ ഓർഗനൈസേഷൻ ഓഫ് 8086. Okay, register organization of 8086. Actually, in generally we can classify the registers into two categories. One is general purpose registers and next one is special function register or special purpose register. Here in 8086 microprocessor, we will categorize the registers into 4 groups. Okay, we are categorizing the registers into mainly 4 groups. These are the different groups. That is, one, it is general purpose register, or we can call it as general data register. This one, general data register. That is AX, BX, CX, and DX. These are the 4 general data registers. Okay, so first category is, or first group is general data register. The next group is segment register. Okay, 4 segment registers are there: CS, SS, DS, and ES. Then next is flag register, flags or PSW. Okay, flags or PSW, program status word. That is another group. Then last one is pointers and index register. So these are the 4 different types of registers we are using the 8086. That is, one is general data register, that is AX, BX, CX, and DX. Then segment register, that is CS, SS, DS, and ES. CS means code segment, SS means stack segment, DS means data segment, and ES means it is extra segment. Okay, then flag registers. Then last one is pointers and index registers. We can see each registers in detail. First one is general data register. General data register. So these are the general data register. That is, actually these general data registers are 16-bit register. 16-bit registers. That is AX, BX, CX, and DX. Okay, AX, BX, CX, and DX. First one is AX. Here AX register, we will call it as an accumulator. Okay, accumulator. In 8085, we already discussed that. What is the duty of an accumulator? Here, AX register is the accumulator register. Actually, it is a 16-bit register. 16-bit accumulator. Actually, what is the duty of an accumulator? It is used to store the result. And also, while performing some operation, sometimes one of the operand will be stored in the accumulator. Okay, so that is accumulator. So here, actually, X is a 16-bit accumulator, and the lower 8 bits of X are designated to use AL, and the higher 8 bits are AS. That means we can divide the accumulator register, 16-bit register, into 2 registers, 2 8-bit registers, AL and AH. That means AL can be used as an 8-bit accumulator for 8-bit operations. Okay, so that is accumulator. The next one is base register. Base register. We will call it as BX. That is base register. Actually, the base registers are used to store the offset value. In case of some addressing modes and roles, we will use these base registers to store the offset value. Okay, that is what I have written here. The register BX is used as an address register to form physical address in case of certain addressing mode. Okay, so BX register is used as an address register in case of certain addressing modes. Different addressing modes are there in 8086 that we can discuss in the second unit. Okay, so BX register is there. It is also a 16-bit register. We will divide that into two 8-bit register. 8-bit lower register we will call it as a BL, and higher bit register it will call it as a. So this is BL. Okay, lower 8-bit it is BL. BL and sorry, it's lower. Oh, here it is. Lower 8-bit register, we will call it as BL, and higher 8-bit register, it is called as a BH register. Okay. Then next one is CX register. CX register, it is a count register. Count register. So actually, CS register is also a 16-bit register. We can divide that into two 8-bit register, that is CL and CH. Okay, CL and CH. Okay, actually this count register is used as a default counter in case of some string and loop instructions. Okay, so for performing string operations and loop operations in an instruction, these count register act as the default counter. That is, counter register can be used as a counter in string manipulation operations and all. Okay. So that is count register. You need to remember this point that it is a 16-bit register. We will divide that into two, that is CL and CH. Okay, and also this counter registers mainly used as a counter in string manipulation and shift or rotate instructions. Okay. Then next one is DX register, that is data register. Okay. Actually, this DX register is a general purpose register which may be used in implicit operand or destination. Okay. In case of few instructions. That means DS is used as a destination register to store the result. Okay, by after performing the operation, suppose if you are performing an arithmetic or logical operation, then after performing the operation, sometimes to store the result, we will use this DX register. Okay, DX register. So it is also a 16-bit register. We will divide that into two, that is DL and DS. Okay, so these are the different general purpose registers in 8086 microprocessor. AX accumulator, BX base register, CX that is count register, and DX that is data register. Okay. So first category is over. This one is over. Okay. Next we can discuss the pointers that are present in the microprocessor. Okay. Here different pointers are there. First pointer is stack pointer. Okay. What is the duty of a stack pointer? Stack pointer points the program stack. Okay, stack pointer register point the program stack. That means stack pointer will store the address of the stack segment. Okay, stack pointer. What are the contents that is present in the stack pointer? It contains the address of the or base address of the stack pointer. Okay, and another pointer is there, that is base pointer. Base pointer is actually it is behave like a stack pointer, but only the difference is that base pointer can be used to access other segments also. Okay, so that is base pointer. Then Another pointer register is instruction pointer that we already discussed that. What is the duty of an instruction register? Instruction register will hold the address of the next instruction that is to be executed. That means it will hold the memory address of the next instruction. That is instruction pointer. Okay, or we can call it as a instruction pointer register. Instruction pointer register is hold the address of the next instruction to be executed or to be fetched from the memory. Okay, it contains the offset of the next word of instruction code instead of its actual address. So that is instruction pointer. So these are the different pointer registers in 8086. Okay, pointer. Stack pointer is the, base pointer is the, and instruction pointer. Then next index register that we can discuss in the next class. Okay. So ഇന്ന് നമ്മൾ ഡിസ്കസ് ചെയ്തത് ആർക്കിടെക്ചറും അതുപോലെ തന്നെ ജനറൽ രജിസ്റ്റർ ഓർഗനൈസേഷന്റെ ജനറൽ പർപ്പസ് രജിസ്റ്റേഴ്സും ഡിസ്കസ് ചെയ്തു, പോയിന്റേഴ്സും ഡിസ്കസ് ചെയ്തു. ഇതിൽ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ നിങ്ങൾക്ക്? ഡൗട്ട്സ് ഉണ്ടെങ്കിൽ ഇപ്പൊ ചോദിക്കാം. ഓക്കെ, അങ്ങനെയാണെങ്കിൽ നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ആശിഷ്, അഭിനവ്, അഭിഷേക്, ആദിത്യ, ഐശ്വര്യ, അഖിൽ സി വി, അഖിൽ കെ, അമൽ, അമൽ സുരേന്ദ്രൻ, ആമിന, അനൈന, അനിരുദ്ധ്, അൻഷിത, അനൂജ, അനുപമ, ആരോമൽ, അർപ്പിത്, അരുൺദത്ത്, അശ്വിൻ, ഫസ്ന, ഫാത്തിമത്തുൽ റംഷാദ, ഋതുൽ, ജറീഷ്, ഖദീജ, ലിഖിത്, മറിയം ലിയാന, മിഥുൻ, മുഹമ്മദ് നാസിഫ്, റാസി, മുഹമ്മദ് മിനാജ്, മുഹമ്മദ് നിഹാൽ, മുഹമ്മദ് സാലിഹ്, മുഹമ്മദ് ഷഫീഖ്, നബീൽ, Nanda, Nandita, Nivedya, Prince, Nuha, Rishikesh, Rishin, Ritik, Rohit, Safil, Sankirtana, Sarang, Sejal, Shabin, Sevin, Shishaj, Tanushree, Teja, Tulasi, Vaishnavi, Vishnu, Vaishnav, Yadav, Amal. Okay. അടുത്ത ക്ലാസ്. താങ്ക് യു.